Recording in progress.
Yeah, good evening. You studied Java up to 1.5 features. Okay. Next version, year, new features. Version, year, new features. Say JDK 1.6. JDK 1.6 introduced in 2006. In 2006 1.6 version, no new features, so no changes at language level. So 1.6 version, language not changed, but library changes, JVM changes, many are there. Later JDK 1.7 version, 2011. Binary literals, underscores in numeric literals, third one, strings in switch statement, fourth one, try with resource statement, fifth one, handling multiple exceptions, with single catch block. Sixth one, generic type inference. Six features in 1.7. Version, year, new features. JDK 1.6, no changes. JDK 1.7, 6 features. Binary literals, underscores in numeric literals, strings in switch statement, try with resource statement, handling multiple exceptions with single catch block, generic type inference. JDK 1.8, 2014. New date and time API. It is actually library changes, but it is important. That's what you have to learn. Next, default methods in interface. Static methods in interface. Functional interfaces at functional interface annotation. Lambda expressions. predefined functional interfaces, method references, constructor references, uh, one more stream API also. Okay, I'll give on 10th one, stream API. It is also important. See 1.8, 10 new features. So 1.8, Java 8 or Java 1, JDK 1.8 or Java SE 8, you can call. So 1.8, many changes are there. Over. Up to 1.8 we'll see later remaining. JDK 1.6, JDK 1.7, JDK 1.8. This is, you can call it as JDK 1.8 or Java 8 or Java SE 8. Okay, like that you can call. Is it over? Writing is over. So 1.6 version, JDK 1.6 version 2006, later 5 years gap it has taken. 5 years gap, 1.7 came. Later 3 years gap. 1.8 onwards, 2014 to every 6 months new version is coming. Now 18th version going on, 18. Now every 6 months new version is coming. But features are less, but 6 months new version is coming. Features, more features are only 1.8. 1.8 only 10 features you observe. 10 new features introduced. Now 1.6 no features at language level. Now 1.7 binary literals. Binary literals is over. While teaching wrapper class, I explained, I think. Is over. 0B, 0, octal, hexadecimal, that is. So no. So binary literals also completed. By prefixing 0B, binary number. See, suppose in a program, See, int a equal to 0b. If I write like this, that is called binary literal. System dot out dot println a. What is the output comes? Binary converted into decimal. You will get output 8. While teaching wrapper class, I taught, I think. So no, binary, octal, hexadecimal, decimal. Say Java C demo dot Java. Java demo. Output 8. Like 1000. It is binary number. It is binary literal. So 1000. How will calculate into decimal? 2 power 0 into 0, 2 power 0, 1 into 0, 2 power 2 into 0, 2 power 3 into 0. Okay, like that you'll get 8. So 2 power 3 into 1 plus 2 power 2 into 0. Two power 3 into 1, 2 power 2 into 0, 2 power 1 into 0, 2 power 0 into 0. At last 8. 8 plus 0 plus 0 plus 0. At last 8 comes. This is binary literal. Okay. So binary literal prefixed with 0b. Octal literal prefixed with 0. Hexadecimal prefixed with 0x. This program already. Next concept, underscores in numeric literals. Next write it, underscores in numeric literals. Underscores in numeric literals. This is not completed. Completed, no? Next, underscores in numeric literals. This feature allows to write any number of underscore symbols This feature allows to write any number of underscore symbols in integer literal and floating point literal. Underscores in numeric literals. This feature allows to write any number of underscore symbols in integer literal and floating point literal. So it is only benefit, only reading purpose. The reading becomes easy. This feature allows to write any number of underscore symbols in integer literal and floating point literal. Now see, suppose integer mobile number, suppose mobile number, different mobile numbers, different types will write. See, different types will read. Suppose example 9885 24 365, like this one number. Okay. Here, how will read while giving a number? You will never read 9 crores 9 lakhs like that. Okay. You will read 9885 24 365. Different numbers, different types you will read. While reading, wherever you are giving a break, there you can write one underscore. So 9885. After this 24. After that 365. Like that I given. So like this, you can add underscores. Then if it is like this and if it is like this, you compare, it appears good, reading purpose. So wherever you are giving a break, there you write one underscore. Then while printing without underscore, only printed. See, while printing without underscore, printed, only reading, programming allowed. See, compilation, execution, like this. Right, this one. This is advantage. That's it. Only readability is advantage. No other. So underscores, if you write, no error. Any literal, integer literal, floating point literal. The only reading purpose, no other benefits. No other benefits, only reading. Wherever you are giving a break, there you write one underscore. Okay. But at the end, at the beginning, if you write error value, see, suppose if I write here, it's an error. See, file, save. If I write at the beginning, it's an error. Cannot find symbol. You are getting error. Okay. So at the beginning, at the end, you cannot write. I'll give some examples. See examples. Say int a equal to underscore, like this. If you write, it is not valid. Integer b equal to, see, 5 underscore 5, it is valid. It is error. It is valid. Okay. Integer b equal to 55 underscore, it's an error. Suppose float a equal to 5.34 f, we are writing. Suppose 3 underscore, if you write, it is valid. Suppose if you write float a equal to 5.5 underscore 0.3, if you write, it is also error. Like before integer part also error, after integer part error, after float point error, like this. It's an error. Float a equal to or b equal to something. Here 5._34.f, it is also error. Float a equal to 5.34 underscore f, also error. So before point, after point also error. Before f, after f also error. That should be in between numbers. Then only valid. So here at the beginning, error. Here at the end, error. Here before dot, error. Here after dot error, before F error, after F also error. Okay. Is it over? This is about underscores in numeric literals. Next, strings in switch statement. Next, strings in switch statement. Write it. Strings in switch statement. So before JDK 1.7, string supported, switch statement supported only integers and characters, but a 1.7 onwards strings also. This feature allows to pass string literals just strings, write it enough. This feature allows to pass strings in a switch statement. This feature allows to pass strings in a switch statement. So previously switch case, it was allowed only integers and characters, but now strings also allowed. Over. Say, suppose switch aux of 0. Aux of 0 which type? Which type? String type. It is string only, no? So like this aux of 0 are written. Suppose case MON. I want to display Monday. Okay. This is after this break. Case TUE. Tuesday. Break. So like this only 7 cases you can write. At last. Default. Invalid. You can write. Say file, save. At the command prompt you have to pass argument received here, that is aux of 0. File, save. Say compilation. While executing, if you pass MON, Monday. If you pass TUE, Tuesday. If you pass any other, invalid. Okay. This is not done. Strings also we can pass. Previously only integer full character was allowed. This switch case totally changed in Java 12. That is also explained. Java 12 switch expressions came. 12th version again updated, modified. So at the command prompt, if you pass MON, that is received here. First argument aux of 0. If it is matched, Monday printed, it will break. If it is not matched, second case. If it is matched, Tuesday printed, it will break. If all not matched, invalid comes. Is it over? Next, try with resource statement. It is completed now. This is alternative to which concept? Now try with resource statement, alternative to which concept? What is it? I taught this one. Try with a resource statement in a file input stream, file output stream. At that time I taught, no? Instead of which concept we use try with resource? What is it? Finally block. Finally block. It is an alternative to a finally block. So it is already over. It is equivalent to finally block. So it is over. Handling multiple exception with single catch block. It is also completed, no? Which symbol will write to handle multiple exceptions? In a catch block only, multiple exceptions purpose we will write like this, no? Catch here, IO exception. After that, one more exception also I want to write. Which symbol will write? You studied, no, this one? This is called handling multiple exceptions. IO exception, pipe symbol, SQL exception. It is R, bitwise R will call. Pipe symbol also you can call. Like this, you can write n number of multiple exceptions. It is over. I taught in the exception handling, try with catch syntaxes I given. Try catch examples. Okay. Handling multiple exception with single catch block. It is also over. Next, generic type inference. It is also over. Nothing but this is while creating array list. Integer AL equal to new array list. This is another way we can write like this, no? This is only inference, allowing. Inference nothing but allowing. This concept you can write in this way. That is only generic type inference. It is also over. Now Java 8 features. These are most important features. Java 8. Okay. Now new date and time API. Java.time package. In this classes, local date, local time, local date time. New date and time API. Java.time package, classes, local date, local time, local date time. So old date class, that is almost outdated. They stopped to use in real time. These classes they are using. If you want only date, local date. If you want only time, local time. If you want both, local date time. As compared to the previous class, these are powerful classes. How it is powerful, I'll explain. So previously to display time and date, we used date class only, java.util package. What is today's date? 18th May. 18th May. After 1 month, 18th June. Okay. After 1 year, 18th May 2023. Okay. After 100 days, you cannot give answer, no. You have to calculate. Okay. After 10 weeks, again you have to calculate. But here we have a library. Plus days, plus months, plus weeks, plus years. Like that, minus back also. 100 days back, which date was there? 100 days back, 100 weeks, 10 weeks back, which date was there? That is also it will give. That's what these are powerful classes. Okay. See, Java P, Java dot time dot local date. I'll explain this class, remaining all same style. Now here, methods. Now method if you call, it returns today's date. And other methods, many are there. So plus days, plus months, see, plus years, plus months, like this, many methods are there. Minus also. See? So forward, backward, both possible. These are not done. Plus years, plus months, plus weeks, plus days, minus years, minus months, minus weeks, minus days. So 100 days back also we can find out. 10 weeks back also we can find out. So 10, 20 years also back also we can find out. Back also possible, forward also possible. First method now, that is today's date comes. Is it over? See, first method, instance method or class method. Remaining methods. Now, first method I want to call. How to call? Complete direct question. How to call? What we have tried, give me answer. Return type also. Local date. Some reference LD equal to. Next. Local date dot now. See. Here. Local date. Some LD equal to local date dot now. It is static method. We have to call with class name. Okay. Return type also local date. Now this class is available in which package? Time package. Okay. Now we have to print system.out.print LD. Implicitly toString method called. With that date printed. File save. Compilation. Execution. See 2022 May 18. Now I want after 100 days. Which method required? Plus days. What is the return type? For calling this method, a reference required. No? Reference already we have. LD. So local date LD2 equal to LD dot plus days 100. Then 100 days, after 100 days, which date comes? That date comes. See. Compilation, execution. See. 2022 May 18. After 100 days, 2022 August 26. Okay. Right, this one. Advanced Java not yet decided. I'll inform. Maybe after this batch only. Maybe. See, it is static method. I'm calling with class name. Local date dot now. Return type also local date. Okay. It is toString method called local today's date printed. Today's date onwards 100 days. That date returned. That is printed. Okay. This is local date. Now Like this only, minus years, minus months, minus weeks, minus days, these all you can call. Like this only, time purpose, time class, plus hours, plus minutes, plus seconds, plus nanoseconds, milliseconds, methods are there. That is only new date and time API. Next one, default methods in interface. Next, default methods in interface. Spring batch also not yet decided. Next, default methods in interface. Note on. Or default methods in interface. Default methods in interface. Default methods in interface. You already studied interface. What is interface? It is a collection of public static final variables and public abstract methods. But the definition changed from 8 onwards. Now, not only abstract method, we can write concrete methods also. This feature is that one only. So write this feature. This feature allows to write concrete methods in interface by prefixing default keyword. This feature allows to write concrete method in interface by prefixing default keyword. This feature allows to write concrete method in interface by prefixing default keyword. Is it over? See, I'll write one interface test here, void show. If I write, that is by default public, by default abstract. You study it. Okay. Now file, save. If I compile, it will compile. Okay. Suppose here, if I write open brace, close brace, will it compile? If I write open brace, close brace, will it compile? No. File, save. If I compile, see, you'll get one error. Interface abstract methods cannot have body. Open brace to close brace is called body, but abstract methods cannot have body. We are getting error. But once if I write a default keyword, it is valid. Now see, file, save, compilation. See, compile now. So if you want to write a concrete method, you need to prefix default keyword. Then we can. Now you can write like this. It is valid now. System.out.println welcome. If I write. Now I want to call this method. Now is it instance method or class method? How many ways to access? What are those? How to call this method? Can we create object to interface? No. What do we do? Implements. Implements test. Next. Next. What do we write? Demo D equal to new demo. Next. D dot show. Okay. See, subclass object. subclass reference. Using subclass object, subclass reference. So you can call superclass members, no? So file, save. Compilation, execution. Okay. But can I write like this? Is it valid or not valid? Valid or not valid? Valid. How it is valid? This concept is called, what is? Downcasting. Is it downcasting? Upcasting. So it is also valid. Demo is a subclass. Subclass object assigned to super interface reference. Upcasting. With upcasting feature, this line is valid. Like this also you can access. See file, save. Compilation, execution. So this is a new concept. This is new concept. This is, say, default method is new concept. This is not a new concept. It already studied. Okay. Calling already you studied. Now concrete method we written, you observe. Concrete method is new concept. Write example. Concrete method is new concept. But a default keyword, if you prefix, then only concrete method we can write. If you don't write default, what it will understand is it abstract method it will understand. Abstract method cannot have body. That's what error comes. Because by default, all methods are public abstract, like that you learn, no? But default keyword, if you prefix, it is new feature like. Then it will understand new feature. If you don't write default keyword, that will become public abstract. But public abstract is there, body not possible. That's what error comes. Okay. Is it over? So this feature allows to write concrete methods in interface. Next, static methods in interface. Now this feature allows to write this feature allows to write concrete instance. This one you write like this, concrete instance methods. Previous concept, this feature allows to write concrete instance methods in interface. Concrete instance method, write it. concrete instance methods in interface by prefixing default keyword. Now you write this feature allows to write static concrete static methods, concrete class methods in interface. This feature allows to write concrete class methods in interface. Previous concept, concrete instance methods. Concrete instance methods only default keyword. Concrete class method default keyword not required. Normal static keyword only. So this feature allows to write concrete instance methods in interface by prefixing default keyword. This feature allows to write concrete class methods in interface. Class method means static keyword. The static keyword normal. So in previous concept, just you add instance keyword, instance word. This feature allows to write concrete instance method. This feature allows to write concrete class method. Is it over? See. Like this. How many ways to access class method? What are those? Directly, class name, object, object reference. How many ways not recommended? What are those? When we can use directly? When we have this class name? Now, I want to call that method in demo class. What we have tried? Now, implements also not required. Implements not required. No? How to call? That's it. Test dot show. Class name interface also one dot class file generated. So interface name dot show. That's it. See, file save. Now object not required. That's what implementation not required. All right, example. It is static method, class method with class name like interface name. Is it over? Now see, it is over, it is over, it is over. From here to here, complete different appears. Now next one, functional interfaces. Note down. An interface that contains only one abstract method. is called as functional interface. An interface that contains only one abstract method is called as functional interface. Functional interfaces required in functional programming. Functional programming means function can be passed as a parameter to another function and function can return another function. So previously what you studied is passing integers, passing floating point numbers, passing strings, like that you studied. Now function also, method also you can pass to another method. That is functional programming. Method we can pass to another method. Functional interfaces. An interface that contains only one abstract method is called as functional interface. Functional interface required in functional programming. Functional programming means function can be passed as a parameter to another function. Function can return another function also. So see, void show integer a, like this we are ready now. Now that means you are passing integer. Okay, like this float a, you are passing float. String, you are passing string. Like that, function you can pass to another function. That is possible. That is called functional programming. In the programming, you are returning here int. That means you are going to return integer. Like float, you are going to return float. But now function can return another function. Function can return another function. That concept is functional programming. In that functional programming, we required this concept. So to understand this one, you need to wait 1-2 days functional programming. Okay. Now functional interfaces for at this one, these two you will see today. Okay, this see later while teaching this one you'll understand. Now see interface test. If I write void show, is it abstract method or concrete method? Abstract method. But abstract method must be declared with abstract keyword in Java. But how it is valid? Implicitly abstract. Okay. Now in this interface, how many abstract methods are there? This interface is called functional interface. That means previous programs also functional interfaces are there. Just a word introduced functional interface. Okay. It is functional interface. But in this interface, not only abstract method, other concepts you can write. See, next write it. Functional interface can have variables and concrete methods also. Functional interface can have variables and concrete methods also. That means two abstract methods is not functional interface. Other things you can write. Abstract method only one. Okay. Functional interface can have variables and concrete methods also. So only one abstract method is there, functional interface. But with only one abstract method, other variables you can write. Concrete methods also you can write. Okay. That is I'll show you. With the next feature you'll understand. Next feature, at functional interface annotation. It ensures that cannot have more than one abstract method. It ensures that functional interface cannot have more than one abstract method. Annotation. We can inform to compiler it is a functional interface. If it is functional interface, it will compile. If not a functional interface, error comes. It ensures. Now these two at a time I'll explain. At functional interface annotation. It ensures that functional interface cannot have more than one abstract method. Is it over? Now, suppose here class demo main method now test is an interface. Test is an interface. Is it functional interface? Yes or no? Yes, because only one abstract method is there. Okay. Now file, save. I'll compile. Okay, it is successfully compiled. Now void print. Is it functional interface? Is it functional interface? No. File, save. It will compile. It is not functional interface, but it will compile. It can have more than also. I want to inform to compiler it is functional interface. I'll inform. Then what it will do now? Compiler will check whether it is functional interface or not. Now is it functional interface? No. Error comes. So what I am saying to compiler, it is a functional interface. What compiler is saying, it is not a functional interface. I am informing to compiler whether it is functional interface or not. Check it out. I informed. Compiler should checking. After checking, it is showing test is not a functional interface. Okay. So only one abstract method is there. It is okay. See, once if you attach this line, then compiler will take care. If you try to write another method, error comes. Now it compiles. Okay. Now it is functional interface. Suppose if I write like this, is it functional interface? No. Then if you write like this, error comes. It is not a functional interface. Now, is it functional interface? You can find out whether it is right or wrong. If it is compiled successfully means it is functional interface. So it is functional interface. Suppose default void print. Is it functional interface? Yes. You can confirm with compiler. See, successfully compiled. That means it is a functional interface. Now, is it functional interface? No. You can confirm. Error. No, sorry. Is it functional interface? Is it functional interface? No. You can confirm. See, test is not a functional interface because non-overriding abstract method found multiple. Now, so just we can find out, we can inform to compiler it is a functional interface. If it is functional interface, it will compile. If it is not a functional interface, error comes. So this annotation is that purpose. Yesterday given at override. At override I given no. If it is properly overridden, it will compile. Not overridden properly means error comes. If it is functional interface, it will compile. If it is not a functional interface, error comes. Okay. Now, suppose what I will do, just observe. Interface sample extends test. Can I extend interface in another interface? Yes or no? Yes. Interface can be inserted in another interface also. We studied. Okay. Now, test interface inserted in sample interface. Test interface inserted in sample interface. Now, here void display. Okay. Here I am writing functional interface. It is also. Is it functional interface sample? Now test is a functional interface or not? Yes. Now sample is a functional interface or not? Yes. Yes or no? Yes, no, multiple answers coming. Now, how many people answer yes? Just raise your hand. How many people answer no? Remaining people? Only for writing notes you came. Online student respond. How many people answer yes? 1 minute, 1 minute. Now, online students respond. How many people? This is sample is a functional interface. How many people answer is sample is a functional interface? Respond. Just raise your hand. 2 hours. Okay. How many people answer is sample is not a functional interface? $18, $19. Okay. Now my question is, sample is a functional interface or not asked? Now those who given no, why it is no? What is it? The show method also inserted in sample. Then in a sample, how many will be there? 2 will be there. Now in a show, how many abstract methods are there? 2. One is inserted, no? That's what it is not a functional interface. See? File, save. If it is compiled means functional interface. Not compiled means not a functional interface. See, sample is not a functional interface. Because test interface abstract method also inserted in sample. Okay. Now, so this method, abstract method, and that is also came here. That means in a sample interface, how many function abstract methods are there? 2. That's what sample interface is not a functional interface. Got it? Just write this one example. So most abstract method is there. It is not a functional interface. Okay, otherwise write like this. It is a functional interface because it contains only one abstract method. That is show. It is not a functional interface because it contains two abstract methods. So only one abstract method is there, functional interface. More than one abstract method is not a functional interface. But other methods, default methods, static method, variables you can write. So in test interface, how many abstract methods are there? One. In sample interface, two. One is derived from test. Inverted. Okay. Is it over? What is next feature? Lambda expressions. So functional interface, these all required for this one only. Lambda expressions only, that functional programming only. These all only one particular concept. Is all related. So this is over, but these two required for Lambda. So tomorrow class only Lambda expressions will see. One class only, that one only required. Okay. Tomorrow Lambda expressions will see. Tomorrow class. You studied already inner classes. How many types of inner classes? What are those? Member class, static member class, local class, anonymous class is, that is required for tomorrow class. You prepare and come. Anonymous class. Okay. Anonymous class compulsory for Lambda expression. Say anonymous class only, many people are getting confusion. By one more confusion introduced. Okay. You prepare and come for an anonymous class. We'll see tomorrow.